Okay, brilliant. So welcome everyone to the Digital Harbour Foundation. We're here with our third cohort of Raspberry Pi certified educators. Give us a wave, guys. So here's our cohort. Let's keep going around. There's Matt waving, he's very excited over there. And we've got a few guys over here at the front who are going to be one of our first presentations. So our cohort have been working for the past 3 or 4 hours on their own projects and resources, and we've got a first team up here who are going to talk about recycling, I believe. Could you pick a side and sort of pick, like, go either here or over here so we can get you all in shot, guys? Where are you going to go? Yeah, there we go. You're in shot. Brilliant. Right, super. Over to you.
Hi, my name is Deanna Soka. I am from New Summit, Missouri, and I'm a computer science teacher.
My name is Venus Montesoka. I am from Hudson County, New Jersey, and I am a computer programming teacher.
Hi, I'm Nick Yates from right here in Baltimore at Patterson High School, and I teach engineering and computer science.
Hi, my name is Mark Demora. I'm a librarian at the Wacomico Library and a physics professor at the University of Maryland Eastern Shores, which is just outside Salisbury, Maryland.
And we're going to show you our project, Picademy Recycles.
So for our project, just to give you guys a little bit of background, we wanted to use the Raspberry Pis to give students a digital feedback for things that they do in real life, right? So usually people are confronted with 2 options, either recycle or don't recycle. So what we wanted to do was to give positive feedback, right, when we recycle, and then show what can happen in the digital world, in your Minecraft world, what can happen if you don't recycle.
Because the problem is so much in real life, students don't see the effects. They put the object in the trash or the recycle, and then it's gone.
And thankfully, if we trash the Minecraft world, it doesn't affect too much. If we trash our world, we're in trouble. So rather trash the Minecraft world if possible.
So we've actually got 3 Raspberry Pis all running sort of simultaneously. We've got our recycle bin over here. We've got our trash bin over there. And then we've got the Raspberry Pi up on the screen, which is running the Minecraft based on the feedback it receives from those 2 bins.
Okay, so first we can model what happens if somebody recycles.
So basically what we have here is a Raspberry Pi that's connected to one of the IR sensors. And so we put it into this cup in order to try to help it so that it helps detect it and doesn't detect, any interfering things. And in order to make sure that it has actually picked an item, in theory, trash, if a piece of trash is thrown underneath there, then we have some feedback it gives us. It basically says, yay, we've recycled. So as a demonstration, I will wave my hand, and it first of all prints out a number, which tells me how many times I waved it, and it goes straight
Thank you for recycling. A tree has been planted in your honor, right? So to thank our students for recycling, so our Minecraft world can be filled with beautiful trees every time somebody decides to recycle instead of throwing something in the trash.
And can you refresh the Twitter?
Yeah.
Because it also tweets it out to the world.
And the message that it tweets out is the message that I've put in here that also displays.
Yay, we recycled.
And notice
yeah, we've recycled 3 things have been recycled today.
So we have a count that counts the number of things that have been recycled as opposed to the same number of things that have been trashed too.
Do another recycle, see another tree?
Sure. More trees are good things.
Another tree.
Another tree has been planted in your honor.
Twitter doesn't seem to be live updating. We'd have to refresh it, but you get the idea.
You can see that the first one was 20 seconds ago. That's us.
Okay. And then we also have one that displays what happens if you throw trash away. So if you throw something in the trash.
So if the student throws an item in the trash, instead of a tree being planted in their honor.
That's also
Which should be in a similar area.
Do another trash just in case.
Yeah, do another trash. The building is the sign that is,
No winner. So it tweets out.
And then it throws up like a pile of garbage. So it shows you what happens, right? So students often put garbage in the trash instead of recycling. And this is like a visual demonstrator that shows them that the world becomes cluttered by just using the trash instead of recycling. Do you want to do another piece of garbage?
I believe those are just cobwebs, right?
Yeah, those are cobwebs.
Yeah, cobwebs are trash.
And if you want to follow along at home, you can follow the hashtag Picademy Recycles. or the hashtag no bueno trash, and you'll actually see these on Twitter appearing as it happens.
And that's it.
Yeah, well, I'm just going to ask a couple of questions. If our next group, whoever that is, do I know who they are? If they can get themselves set up on one of these screens. So I think that was a really nice project. Yeah, it's really nice to see some sort of social responsibility stuff kind of coming into a project like that. What was the single hardest thing for you to do today?
This thing. I mean, I'm maybe biased. I think it's this thing.
So you struggle with the PIR sensor because you were talking about the sensitivity.
The sensitivity of these things is interesting.
So I think that they can be. There's a little bit of adjustment on them. Sometimes they can be a bit hit and miss.
Yeah.
And I think it's also like when we integrate those into projects, think about how we kind of can make sure what we're capturing is an object passing in front of it. So you may have a funnel or a trap or something, which means you know you're capturing that thing. But we know we've proved the concept at least because we can wave the hand, which is brilliant.
Yeah.
And how did you divide the labour? How did you split things up and decide how you're going to manage that big project?
We kind of made a sprint chart on the board and broke it down into smaller tasks and like the little things we needed to make happen in order to get the larger task done.
Great. And that's a really important thing for your pupils to do, isn't it? Right? To see the value in decomposing a problem and splitting it up. And I love the fact that over there you've got a whiteboard. Yeah. I don't know if you can see that, Sarah, just over that corner over there. Look, there's a whiteboard with little scrawled notes all over it. Kind of, I can't point there. There it is, right there. And it was great to see like all that planning going on. So that's super. Thank you very much. If you want to take a seat, guys, then we'll get the next group set up. Thank you.
Woo!
Thank you. And then actually, while this group is setting up, maybe the next group can be over the other side. We'll focus on this group. The next side could be over. The next group could be over here. Is that group? Yeah, great. While you're presenting, just to help you with timing, Kevin's at the back of the room. Forgotten who Kevin is. There's a wave, Kevin. There. Just look out for Kevin. He's going to give you a prompt as to how long within your 4 minutes you've got. Okay, so just keep an eye on Kevin. 4 so far. 4 so far, right? Okay, great.
You should have Raspberry Pi that.
You want to start introducing yourself while you get set up?
Sure. I'm Mark Snodgrass. I'm from Indianapolis, Indiana, and I'm an engineering teacher.
I'm Kay Ferry. I'm from here in Ellicott City, Maryland, and I'm middle school, upper school STEAM and performing arts teacher.
And I'm Lissa Trummel. I am a Maker Lab guide for the Allen County Public Library in Fort Wayne, Indiana. All right, so you guys want me to? All right, okay. So what we have is a late attendance tracker. So the version we have here in front of us is controlled with a button. We did work on one that would be time controlled. So if you started a class at noon, let's say, and you wanted to track everybody who was late for the 15 minutes, so till 12:15, you would be able to work. But for presentation purposes, the button's a little bit easier to model. So I'm going to go ahead and press the button, right? Oh, hang on, let's run it first. All right, now I am pressing the button. So now I've got a preview up on here, and Mark just ran his hand in front of it. And then in our pictures library, we have a folder for late arrivals, and we can actually see the pictures.
But there you go.
And the pictures are on the screen.
In sequence.
So
Yeah.
we kind of all spent time working with little different parts of it. Our biggest overall challenge was understanding how Python uses the syntax to create date time and what I guess variables that you'd pull from to create date and time. That was the hardest challenge, I thought. Making the hardware work wasn't nearly as hard as trying to create a specific start it at 11:15, end it at 11:30, and then put the pictures in other place. And then that was the other thing we had issues with was time stamping each picture. So don't be late to my class now. There you go.
That's fantastic. Thank you very much. If you guys want to get yourself ready, yeah, that's great. If you might help with that. So I think you were talking about the libraries. I think a few people encountered that, knowing what Python library is to use for certain things.
That's okay, no worries.
So during our day yesterday, we used the time library, which is for just sort of timing. And then the date time library is if you want to know about what time it is. And time stamping pictures is a really great way of making sure you don't overlay them, because every single one is stamped at a different time. What was the biggest challenge? Sorry guys, I was going to ask you. What was the biggest challenge?
Oh, we just did that, but that's cool. The date time was really challenging, and really understanding which variables to pull.
Oh,
and writing the correct syntax was brutal.
Yeah. But you ended up with what, like a 29 program or something?
Yeah, after we deleted a bunch of stuff we really didn't need, it was really much more simple than we made it. So
that's great. That's super. Thank you very much, guys. Well done. Well done. Okay, guys, introduce yourself.
I'm Jen Bishop. I'm from here in Maryland, and I'm a public librarian.
I'm James Kinski, and I teach high school computer science in Delaware. So the game we created was a Minecraft gold block hunter. It's kind of like geocaching, where it's going to randomly generate a bunch of gold blocks, hide them underground, and it's your job to try and find as many blocks as possible within the given time limit. So we're going to start it.
We actually have a button. Push the button to start.
So it may take a little bit to get it initially set up.
We had to figure out how to make a flat world instead of the random one where we had things we could not control. So it actually tells us the distance to the next block. You start with a red light, so we added the traffic light. So you start with a red light. It's telling us the distance. It updates as it moves. And then when we get to a certain distance away, once we get under 40, then we're going to, you see our traffic light will change to yellow.
Oh, man. I think you saw Pokemon's tracking program.
Yeah.
Oh, there you go.
Yeah.
I actually don't play Pokemon, but I'm sorry. But I do know what it is. All right, so watch. Oh, yellow. Oh, I'm sorry.
So now at this point, we should be able to see the torch somewhere in the background.
You're 30-something.
Yeah, we needed a visual to find, so he has it so it'll place a torch right over our spot. So once we get close, we kind of have a good idea.
Oh yeah.
Oh my God.
All right, watch the traffic light.
Oh,
It's also randomly generated as far as how deep underground it is.
Oh, you got it.
Now we're going to the next one. Our light is back to red.
Oh my goodness.
Oh, yellow, you're close.
Too far.
That is awesome.
Watch. There it is. There it is. There it is.
There it is.
That's the wrong one. That was the
We had a torch for our starting location too, so I think that's what that is.
Fell in the hole.
Oh, now we're done.
So if we had more time, we would have also set it up so that when the light changes, it would have switched from red to yellow based on if you're actually getting closer to it rather than just based on how far away you are. So.
Yep, and then we did have a timer, so we set it to 2 minutes for the demonstration, so our time was up. And it'll tell us how many we got. I think it already went away, but
Yeah.
so yeah.
Wow.
There you go.
So you said at the beginning you've got a flat world there. How
Yeah.
do you make the world flat out of interest?
We looked that up online.
So we found that we had to first completely clear out the world. So we used the idea of making a giant cube. So it was a giant cube of air. And then we did a giant cube of just dirt for the ground layer, and then a giant cube for the grass overlay of the dirt.
Right, so it's got 3 lines of code, right? It's a really simple kind of process, but the effect is pretty obvious. And the other question I was going to ask, I've forgotten. No, it's gone. Never mind. Thank you very much. That was an awesome project, guys. Well done. Well done.
Using a projector?
into the projector just from the macro, right?
Yeah. So again, it's nice to see, and we've seen a few projects like this where we've got two elements that we looked at yesterday smashed together. We've got physical world, we've got Python, and Minecraft, all kind of working together to create a very simple game. Oh, that was the question. How many lines of code, James, was that? Like 30 odd?
Probably like 100.
Oh, 100. Yeah. Oh, yeah. I suppose it's quite a bit of that. That's good. But it's not a long program, right?
Not overly long.
Yeah.
But it looked a lot better after we went back and changed it to functions instead.
Yeah.
It was a little unwieldy.
Yeah. That's great. Thank you. Okay, you guys ready?
So my name is Maggie Powers, and I'm a Director of STEAM Innovation at the Agnes Irwin School outside of Philadelphia.
I'm Janice Mack, teacher on assignment from Phoenix, Arizona.
I'm Angie Potts, instructional coach from Minnesota.
Gabrielle Shamba, middle school CTE teacher from Charlottesville, Virginia.
Nathan Seckinger, middle school librarian at Fredericksburg, Virginia.
We are the Twitter Bug team, and we want to find a way to help students and teachers capture innovations and things that they're making in their school. So we'll give you a little tour of our process right here with our video. So our hope is to be able to do one live tweet here with our Twitter bug. And so we'll hopefully it'll come up here and can drive around the school. And then when you're ready, you can pause it and take your picture and it'll get tweeted out ideally with a school hashtag that will be attached as part of our code. So we'll test it.
All right, you ready? All right, here we go. 1, 2, 3.
When the light goes off there, then hopefully. Reload it.
Still in it.
Oh, wow.
Oh.
Wait for it.
I gotta pop up over here.
This is extremely suspenseful.
No, it's here. Still resolving.
Well, we can talk about it.
Oh, yeah.
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 Do you want to show up?
Posted.
Yeah.
It's up. It's posted.
Nice.
The tweet, he just took, the picture just took, the edition.
It's frozen right now here. So.
You keep going.
Don't
worry,
We
it's on
started with the
Twitter.
body. We worked on, a chassis for the body with the motor drive. There it
Well,
goes.
there goes. So we used the Explorer hat to power the motors in Python 3, and we used the touchpad here, 1 for go and 2 for stop.
And then we added a button to control. We were hoping to control both the motors and the camera, but that was a little tricky. So instead we have the touchpad for the motors and the button for the camera piece. Talk about the camera.
Yeah, so we are still working on the camera piece because right now, as far as we got, is that you push the button once, it takes a picture, and then it's done. And we would love for that to be able to continue, that as it goes, every time you see it, you can hit the button and take a picture, but we didn't get to that piece yet.
I think as far as considering how it relates to the classroom, I think we teach the engineering design process and the process of iteration, and it was really great to live that today as we were going through it, because we were like, oh, we did this, but now we created a message. Now we want to create a randomized message. So then we tried to figure out how to do that. So it was just like we kept iterating up until the last minute, honestly, and we were like, this is what we would do next. So I think it's great that we model that for our students, experience it ourselves, and bring that to the classroom.
Yes, this is one of 5 random messages that will be tweeted out whenever it runs.
That's fantastic, guys. Well done. I think perhaps my only question is around, like, how long did the video take compared to the robot? I think that's possibly our first Picademy promo video.
It took me 2 minutes to make. I can show you.
No, it's brilliant. It's really cool. And just at the end, you guys had to experience a little bit of a challenge, didn't you, with Python 2 and 3?
Yes.
So it's really important. We all the things that we write in our resources, we tend to do Python 3. You will find out there in the community sometimes there's Python 2 kind of legacy libraries. You can stick with 3, but then make sure when you're running your code, you're running it in the correct version of Python. Okay. So I think these guys are just about there. And then if our next group want to sort of set up in the background, that'd be fantastic.
Okay, so let us introduce ourselves. We are, I think we're good. Yeah, we are Pleasantly Pie. We have a team name. And we made a magic mirror. And I'm Alyssa Malaspina. I'm a teacher librarian in New Jersey.
I'm Juan Valentin. I'm an education program advisor at the U.S. Patent and Trademark Office.
Joel Bruns, librarian at Westfield High School in Indiana.
Heather Lister, teacher librarian and consultant for Mackin Educational Resources.
Great. So I guess
We're gonna demo it.
We'll demo first, and then we'll get into it.
I'm a mom of a 3-year-old and a 10-month-old. So when I wake up and I go into the bathroom, it's a little scary. So we made the magic mirror. So just pretend that this monitor is a mirror. So I'm going to come in and start doing the makeup. And we're just going to pretend that the sensor isn't.
Not fidgety and
come on.
It likes to work when it wants to work. And
It worked for us.
yeah, it works. You know it works. You know it works. Move.
It's disconnected.
You know, it's
Exactly.
disconnected.
Kate
Lesson learned. There we go.
Run it again.
It should.
There we go.
I can
Okay,
tell you're going to have a great day today.
And then you get happy, and then it takes a selfie of you.
So
we're going to have a
So
we're
we're gonna rerun that. All right, here we
There's
go.
audio, guys, so we need to make sure we can hear it.
Turn up the speakers. They're as high as they go. All right. Give it a go.
And I realized like people see me.
You look beautiful.
So then, our next iteration, if we had a half hour longer, we would have actually had this on TV and display. You can't really see it, but in white letters there, it says, "You look beautiful." So then these pictures will display on the screen throughout the day. As people who walk through this mirror or in your house, you can be reminded of the compliments that the smart mirror is giving you.
And this idea sort of came from the Harry Potter thing. So I was thinking, okay, yeah, you have your pictures around Hogwarts, but it would be great if they would just like compliment you all the time. So we thought, okay, a mirror. Yesterday in the raffle, I won one of the Grove Pie kits, and there's an LED or LCD display that you can attach to it. And so talk about failures. I spent the whole time trying to figure out how to work that. And it obviously didn't. But we did find out it wasn't my fault. It's something with the installation. We had a lot of help for that. But
and the reason why Joel's in our group is because this extension has multiple applications, and we basically have the same core, but Joel took it in a different direction.
So I was working on a variation of essentially the same thing minus the camera. I was creating a series of buttons that would correspond to different audio files. I got the audio files to work, I got the buttons to work, but I never got the two to come together. So a little bit of failure there too, but we'll get there. So yeah.
That's great. Fantastic job. Thank you. Someone's tweeted that picture of Heather, right? If not, grab it quick. That was really great, guys. It was really great to see you guys work because I think you split the task up really, really well. And I think you had lots of little complexities, like you recorded the sound, we had to convert it.
Yeah.
So we learned a little bit about installing software.
We learned about
files.
randomizing because we wanted to randomize we did like 6 sounds. So all 6 sounds, we had to sort of randomize them and then make sure that the corresponding words went with the sounds that we made so that, you only heard like 2, but there's 6 of them that come up every time a motion comes.
And there was a really interesting question that Alyssa asked at one point. I made mistakes in their code, and we put random stuff in, but we'd forgotten to import random.
True.
And it was we've kind of asked this question around how do you know to import random? Like, how do you know that there's this thing random that will do randomization for you? And I kind of modeled. There's a really great website for this kind of thing. We just Googled choose a random thing from list Python, and the first hit is inevitably Stack Overflow, which is just a forum of like questions about code, and it will just say like, here's an example, 3 lines, import this, do this, random this, it's done. So it's a really great place to go, and as you discover new Python libraries, you'll find sort of great uses for them. So it's about experience. Over to Bob and Mike.
Well, I am Master, and this is Polygona. These are Minecraft names. We don't have a team name, but those are our Minecraft names. So I had the great idea of doing a selfie, digitizing it, and putting it into Minecraft. And we've kind of hooked it up with a button. And so you want to talk about this?
Yeah, so our first iteration was that we wanted to get kids involved in the physical world because in the Minecraft world, they're excellent at just creating stuff. But we wanted to let them know that there's a connection with the physical world. So we thought, from what we learned this week, we wanted to just try the PIR. So we then hacked that. So using the sword, you could just pretend like you're slicing a block, and it will take a selfie and then digitize it. And then as we were going through that, we had encountered some problems, and we didn't know if it was either our code or the sensor. So then we switched that to the button. And so if we had more time, we would be tweaking and stuff. But here we go.
So you need the average.
Yeah.
Okay. All righty. So the code's kind of a little mashup of several different things that we kind of ran, and hopefully it'll all. Ready?
Yep.
Okay. It's pointing this way.
Just hit it. Yeah.
This is the part where it works.
Okay.
So I took the picture. Now we go back to the game.
And you'll see it render.
Oh,
that is awesome. Wow.
Takes a little, not as long as you might think.
Oh, wow.
So he has his very own selfie in Minecraft. And actually, the Minecraft world here is littered with other selfies, as far as the eye can see. But that's the one right there of Babbage with this beautiful Minecraft sword.
I think it's a really doable, fun project, and I hope you guys try it out. It's really fun.
That's awesome, guys. Really well done. Thank you. I think there's a nice extension there. Like you could work out, because you were kind of moving there around manually, you could work out what the ideal position is to view the picture, teleport the player there so they can see the picture. You could talk to the kids about what images are and the fact they're made of blocks and how. And so I guess you've just downscaled that picture, and then use different blocks to represent colors, right? So you can kind of talk to that process.
Yeah.
You get kids to do some color swapping. There's all sorts of things there. Fantastic. Thank you very much. So you guys ready?
Yeah.
Introduce yourself. I'm Natasha Daniels, and
I'm an instructional technology specialist at Round Rock ISD, which is right outside of Austin.
I'm Carmela Doty, and I'm instructional specialist with Prince George's County Schools, and I also teach at Trinity Washington University instructional technology.
Chris Pointer, I teach ESL in Western City Schools. So today, what we failed at frequently and often was making a photo booth.
It looks great.
Thank you.
Thank you. My iPad.
I like that kind of positivity. The theory is this: that there would simply be a button. You could push the button. There would be a display within the box that would just mirror your own image, so you could kind of pose yourself a little bit. It would then take a picture, house that picture, and then email it through Gmail to wherever we wanted. So we could store it and then house it and then manipulate it however we see fit.
Yeah, and the idea was that students who did work, like say that they did a project, they could come up in the front with their project, hold it up, take a button of what they were working on.
Because I work part-time, so that was my whole thinking, is that I'm not there all the time to take pictures. So, and I still have to control the school's Twitter feed and website. So I want the kids to be empowered, but I didn't want to go straight to Twitter. I needed it to go to Gmail.
And we got this end of it working pretty well. I think one of the things that we learned today is that Google hates the UK. We really, really struggled with getting the coding to work for Gmail.
So, but we did, like, I can't give this man enough high fives, because like we started it all together and then he just took it head on. High five, please.
We didn't get it to work today,
Right,
but we're not done. It's gonna work.
I'm so proud of all the work that we did.
And we called them our experts, resident experts here, and they're mind boggled.
Yes, I know it's crazy. We're high-fiving over this box that doesn't work, but we did a lot.
So which bits did work, Natasha? So I think you've got an iPad screen mounted at the
Yes.
moment. Did it work
So I
on a
got the
screen?
VPN, like I downloaded a VPN client here, and then I went through a tutorial to enable the VPN on the Raspberry Pi, which is taped back here in this little case. And so that got working, and then I wrote the code for the camera button. That worked, but we just couldn't get after we get the camera to get to Gmail.
And we basically just ran out of time. That was it. And then we figured out that we found directions for like adding a battery back there, so you could have this little running with a battery back here as an independent unit.
And to be clear, with this level of failure here, I don't want to leave you slightly misconstrued. It's not that we failed to send a picture. We failed to send an email that had a word in it or a letter.
To Google.
That's where we're still at. That was for you, Google.
Yeah. we can Twitter it, but we couldn't send it to Gmail.
Thank you.
Yeah.
Thank you very much, Phil. That's really good. Come on. I think, so I was chatting to Chris quite a lot. There's a really interesting thing here. All of you have used some APIs. So some people have used the Twitter API, some people have used the camera API, and some APIs are better documented than others. And I think the issue you had is that all the examples, Chris, how long were the bits of code for sending an email? Or how much code did you write to send one email?
I think when we were done, we were at least on line 150, 200, at least. Our last syntax error was somewhere around line 85. It was a lot. Yeah.
And it's because there's a huge amount of work. So those of you that have used Twitter today, how many people have used Twitter? So you know that authentication bit you do? Yeah, that bit was probably 20 lines of code for you, and it's quite an involved process. So you think it's going to be straightforward, but it can be really, really tough. So like when we encounter things like that, like speak to Google and say, I want to do this with my kids, you know, and your API sucks. Or it's really hard. They should, you know, the developers have a responsibility to make things accessible and extract that detail away. And actually, when as educators, we can pressure them, and we should do, right? So.
Well, tweet him.
I will tweet him.
Yeah.
Let's talk.
Tell him.
He'll tweet. He does educational development for Google. So let's see if we can connect you two, and maybe you can work that out.
That's great. Thank you so much, guys. You should be really proud. Well done.
I'm Matthew Buckley. I'm an ed tech coach at Bishop McNamara High School in Forestville, Maryland.
And I'm Damien Barity. I teach computer science at the Hill School in Pottstown, Pennsylvania.
And essentially, we made a garden computer. We didn't really come up with a fancy name for it. I think Damien and I are both very good at going places we're not supposed to be, because both of us at some point over the weekend had gone into that little back room and saw that the Digital Harbor Foundation has an Arduino sort of automatic water gardening thing. While we both love that stuff, I was wandering around, we were picking things, and he just sort of said, I was hoping to get into sensors. Like, I was also hoping to get into sensors. And we sort of just came upon this. This was not one of my ideas at all until I talked to him at that point. Then we started looking to see what sensors they had. We talked to James, and he suggested we use the Sense Hat. This is the Sense Hat, which is used for the AstroPi program. Damon and I pretty quickly found out that the Sense Hat doesn't exactly do what we wanted it to do, but we wanted to play with it so badly, we just sort of twisted every other part of our project to make sure that happened. I can keep going. I have a bad habit of talking, so
So I'll just quickly explain what we found. And although this isn't the most ideal thing, we did find that we had a shared passion about the gardening setup. We did find that this sensor does have temperature, humidity, and pressure sensors. So we started looking up like meteorological data and, okay, what's the right range? So what you're seeing right here is it's cycling through, we just have a while loop going, and it's printing out the temperature, the humidity, and then the pressure. And if it is in what we just arbitrarily, we're not botanists, but we just arbitrarily decided what was a nominal range. So if something is a really good temperature, it was going to be green. If it was a little too hot, it's going to be printed with a red background. So we did that just to kind of experiment a little bit more with the display. We were talking about doing bar charts and actually plotting out values, and we quickly realized that we just don't have nearly enough time to do that.
But they already had a scroll message thing, so we just decided to use that. Yeah. We were also very sort of hell-bent at the end. We wanted to make sure that the inputs led to an output as well. So we need your imagination here just a little bit. First off, imagine that we didn't have to hack the Sense Hat, and so when we're hanging over it, imagine that's not happening. At some point, my hand is a rain cloud, and this is a water hose, not a vacuum. And now we will pray. So currently, the humidity in this room is about 40%, and that is too low for our garden. So when we do this,
let's see.
Make it rain.
But then the rainstorm comes along.
It might take a few.
It might take a few seconds. We probably should have made the scroll go a little faster, which we talked about and forgot to do. Maybe I should just breathe on it.
I can just some water. Okay. So we decided just for this demonstration, we just kind of pegged the output of the humidity, saying that, or if we had like a set probes in the soil, if it got dry enough, well, you want to turn on the pumps and water your plants. We could also, for extensions for this, we were thinking that we could do this time, like every 4 hours the water turns on, or we can look at weather and use data like that. So it's really just the start of the platform, and it has all these great places where it could lead us. So
water sensors, all sorts of things like that they have for a lot of the gardening projects, which are just awesome. Thank you.
Brilliant. Thank you guys. I really like the symbolic use of like different elements. Like earlier on, you said we're going to use an LED to represent a motor. You clearly upped your game.
Yeah.
And I heard the Hoover a few times. I just thought you were being really tidy. But no, there we are.
I think the Digital Harbor guys were curious why we're doing that as well.
Yeah,
so
yeah.
kind of like, oh, is that how you're changing the pressure?
So I think we've got one or two more presentations. I think we're trying to get them there. Super. Right. Super. So if our next group can come up.
Hi, I'm Efren Tovar from California, Central California, former ELD teacher, now Director of Technology.
I'm Regina Schaefer. I'm from New Jersey. I am an elementary tech specialist.
My name is Scott Bridges. I teach high school science and technology at Sunlight Academy in Port Bay, Haiti. I'll jump in a little bit. We were working on various kinds of Twitter-based activities, and we didn't come at this from a single project approach. We all had something that we wanted to accomplish
Separately.
Separately.
They just
that
got
way.
together.
I put one up here to demo real quick, and I don't even know that I'll put the Twitter feeds up there, but it should. If you send a tweet and you put the hashtag "how hot is it," you should get a tweet back that tells you how hot it is. So it's going to get hammered.
Hashtag how hot is it?
Hashtag how hot is it?
So we need to send a tweet with that?
Yeah, just text. My thought process on that, where I work, we run, all of our power is generated locally with diesel generators. Everything we have gets hot all the time. Even things that should never really get hot. And so understanding how, what the temperature is doing in an area is kind of nice to know. In particular with diesel generators, the hotter the ambient air temperature is around them, the harder they end up working. That doesn't help them if the air around them is getting hotter. So if we can increase circulation around them, or just understand what they're undergoing while they're running, it's helpful. And so I kind of wanted to put together something that I could just ask it by sending a hashtag that I would know, how hot is it? I wanted the generator room, in my case, that's what I was thinking of, to say, hey, it's this many degrees in the generator room. So anyway, did anybody get anything?
I saw it on your.
Is it, oh no. What? Oh.
So we were running into this with tweeting, that if you have the same status update, like twice in a row or even later, that causes a problem. So if it's still 27.1, and you say it's 27.1, and then you tweet again, it's 27.1, Twitter rejects it.
Oh, so there should have been a 1 out there?
Yeah. You had a timestamp in there that's down to the second. It'll allow that to go through.
See, I'm learning things all the time here. That's what happens when you
I've got a lot with Twitter.
test as a single guy on that. That was interesting. I did run into that right off the bat. I was like, wait a second, if you send 2 tweets out that are identical, it fails. And so I thought I had this worked out so that it would change it up a little bit. So good to know. I know Twitter had gotten better about it. So there was my fail. So it didn't work. It didn't work. It worked at one time.
So really quick, again, from California, Central California, huge digital divide in Central California, and specifically where I reside, we have a lot of students that don't have internet access. So using a Raspberry Pi and using free or low-cost internet through everyoneon.org, which is a great nonprofit organization in the United States to bridge that digital divide. You can get low-cost internet. You can even get free internet, believe it or not. So everyoneon.org. So you connecting a mobile hotspot, connect to a Raspberry Pi. You can actually tweet via a Raspberry Pi. It'll post. So I did 2 posts today. Second phase of this is to actually be able to translate Twitter text into any language. And so I failed in that one, but I think I wrote approximately 200 lines of code. But that's the next thing I'm going to do, be able to automatically translate the tweet in the Raspberry Pi.
My idea was for my library. I'm in a district with 12 elementary schools, but we have no librarians for elementary. We haven't for 6, 7 years. So the parents run the library, and they basically do check in, check out. But we wanted to add some more activities. They're not ready for maker spaces. The parents are not. But they do book talks and things like that. So I thought it would be great if the students could come in and do a book selfie and have that tweeted out. Our district does a lot of Twitter stuff under our hashtag. Middletown Reads, and then also somehow get that bear. I don't know, is it for sale somewhere? And have a button inside the bear where the wee ones, when they come in, can press it and videotape themselves talking about their books. Because they get read to, they read books there, that kind of thing, and then have that go out. But I had an issue with my token in Twitter, and an hour and 45 minutes later, I realized I had to regenerate it, even though I did a million things to figure it out, and so I'm behind in that process.
But you've all got so far with Twitter. We've got mixed success, but we've gone through that process. That's really great. So well done, guys. One round of applause, please.
swap that Good. And let's just turn this all over.
Somebody said they, on the Twitter feed, somebody said that they.
We can talk about it first.
Yeah. Gmail.
So I'm Sean Grimes, met me yesterday. This is Jonathan.
Hi.
So we like challenges. We were told that to do sensor input into Sonic Pi can be challenging, and there's a Python library that sort of kind of works, but you can't do some of the advanced features. So we figured, well, let's see what we could do to come up with some different alternatives. So we actually came up with an Arduino project that interacts with Sonic Pi. It's a little hacky. It's actually a lot hacky. But the bonus is that you can use almost any sensor. So in this case, we're using photoresistors. In this sort of learning to fail process, I was trying to use some EKG or EMG sensors, so you could actually use muscle movements to trigger different audio pieces. Have you started the?
Oh, no, man. So I just wanted, like, one of the inspirations too was making interactive exhibits for the tech center here. So we've talked a little bit in the past here and there about some sort of like audio interactive exhibit, and it was a cool opportunity to try it. So first thing that we did was, there's two parts to this. It's made a regular live loop that'll just run in the background, and so this will be going the whole time, because it still uses the live loop that's built into Sonic Pi. Then we built out some functions that are then going to be triggered by the sensors. So run those. And then we have to plug in the Arduino to make sure I have an active buffer that's clear.
So what the Arduino is going to do is it's actually going to act like a keyboard. And so it's going to interact with Sonic Pi. So the Arduino actually just typed ready. That was not Jonathan or I. And so if we trigger one of these sensors, like button 3, it will make me look silly.
There, so now it is triggering the function called button 2 that is in there. And some of these are a little louder than others. I had really tiny headphones while I was working on it, but we would figure this out before the exhibit. We wanted to make sure that the functions were triggering by the sensors, so that it would have some sort of live interaction for everyone coming into the space and playing with it.
And so what Arduino is actually doing is it's doing a select all, a delete, and then typing out button 1, button 2, button 3, and then doing Control R to run Sonic Pi again, or to run this buffer, which then interacts with the other buffers that have the actual loops and functions running.
And the live loop continues to run because we're not, we're still using Sonic Pi as a standalone tool. So the live loop's able to run in the background. So if we were running this during an event, we might make something a little ambient in the background just to keep going, and then build layers on top of it triggered by the sensors.
So we, like Jonathan said, the installation piece, we could have a piece of wall art where if someone is looking at this piece, a different piece of audio is playing. And if someone is over here looking at this piece, it contributes to the ambient musical experience of the artwork. And then it kind of shifts and changes depending on the different popularities. Or we could have temperature sensors that affect the composure, proximity sensors, light values, all these things that could affect the composition of the music.
And triggering based on thresholds too.
Yes.
So just to show again, so the live loop is running in buffer 0, and then the function definitions are in a separate buffer. So we could keep adding more function definitions based on the amount of sensor triggers that we have. I guess one of the things I'm interested in exploring too is how we can just keep refining this with, I think the latency was actually really small though. It was pretty cool. Yeah.
That's an awesome project, guys. Thank you. Well done. I've seen a few people do like physical computing and Sonic Pi, but I don't think I've ever seen them use an Arduino as a keyboard. It's quite a convoluted route, but it's nice.
It is a total hack.
it all. That's awesome. Really good.
I'll let you do speaker. And I'll... Oh, thank you. That's awesome. So then swap you HDMI for HDMI.
I'll go ahead and start while they're getting set up. My name is Chris Schreiber. I am here in Baltimore area. I'm a digital learning specialist for preschool and lower school at Garrison Forest School in Owings Mills. I teach all girls except my little pre-Ks who are boys and girls.
And I'm Karen Horgan. I am an ESL instructor and technology coach here in Baltimore City at Lakeland Elementary Middle.
Hi everyone, I'm Sarah Thomas. I am a regional technology coordinator in Prince George's County Public Schools, Maryland. So I'm going to turn it over to them and then I'll tell y'all what I did after.
Okay, well, so Chris and I,
I'm a little intimidated by
we jumped
before us, but
we jumped into the deep end. We had a similar idea. We both kind of wanted to have children be able to interact with a simplified interface using physical computing to make cool sounds in Sonic Pi. Am I summarizing that correctly?
Yeah. And to have buttons or some type of input, varying inputs that would pull different sounds, and that you could either overlay them or sort of put them together somehow.
And neither of us really know how to code. So we wound up with a less sophisticated, less successful version of what you guys just knocked out of the park. But so what we have here, I feel like one of the things that we learned how to do and how not to do is to search elements in Sonic Pi, to learn how to search for things in Python libraries, to learn what it meant to be running a certain Python library or to need a certain element. Shall we just try playing it?
Yeah, so what we ended up with and was we were shooting for a very, like I said, a very simple version of what this grand idea in our head was, just simply a button that would start playing a sound, a button that would switch it to another sound, and then a button that would stop everything. We got 2 of the 3. And in varying degrees of 2 of the 3. We could never get all 3.
No.
But
So,
that's to come.
Hashtag future goals.
Yes.
And we've got some buttons. They work, except the one in the middle. Don't look at it.
Yeah.
So, okay, shall we?
All right. We're starting it. Yeah, we're good. Okay, and then green
starts. So you can hear there's 2 layers of sound happening, and we could tinker with the notes and make it play 3 notes or 9 notes or whatever. And then with this underlayer, I guess we could make that as complex as we want. And then there's a button that usually switches it, and this time turned it off.
This time turned it off.
So usually that.
And so we were spending so much time on getting the buttons to integrate. We were pulling what we learned yesterday with using buttons to control that, and pulling that into this code that we found about threads. I'm not really sure we still even understand what that means, but and trying to put together this what we've discovered today with what we learned yesterday. That we didn't even get to the point where we were trying to make some beautiful sounds. So that's why you were hearing that ding, ding, ding.
Yes.
We were like, okay, that's secondary. Yes. We need to just get it to work. And we got there. But what we also realized is that we had some very complicated code here. We actually crashed Sonic Pi a couple of times. We were like, why is it not working? What did we do? And we were like scrutinizing every line of code, and like, no, I don't see it. We don't see it. Finally, we realized Sonic Pi wasn't running.
Yeah.
It had crashed. So.
And I was going to say that one of the takeaways I thought for me was, we shouldn't have started borrowing code that's this complex for something that we don't really understand. But I also feel like since we did, it made me develop a fluency with simple code, like how to tell the button to stop and to wait. That there's pluses and minuses. There are still chunks of this that I don't understand what we're telling the machine to do.
Right,
and there's parts of it that I do now.
Yeah. We had a lot of fun. So that was really good.
And usually it does switch noises.
Yeah, it usually does. So.
Fantastic. Thank you.
My name is Sarah, and I am a perfectionist. That's something that that obviously I'm going to have to get over before my next iteration. My initial idea was pretty big. Thank you to Shayna for suggesting a great idea that I'm not failing because I'm not giving up. But it's about using form data about educators around the world who have connected and using their location and kind of merging that with educational event calendars and just kind of tweeting.
Nice.
Yeah, so tweeting to see what's happening in your area and connecting people that way. So I tried to do that today. Unfortunately, that did not work, so I started to panic, and I decided to switch my project over to Sonic Pi, and just to kind of hack it and try to find different layers and make a composition, which was all well and good, but I wasn't happy with the song. So I went to a third thing and started going and frantically searching, what can I do in 30 minutes with the Raspberry Pi? None of those worked. So I went back to the song. And then when I was trying to tweak the song so I wouldn't embarrass myself up here, then I deleted it. So that was my process for today. So again, I'm going back to the original idea. It might take some time, but I'm definitely looking forward to making that happen. So
thank you, Sarah. And just before our next group start, I want to address a point that Karen made and also that Sarah made around the quality of sound. Right, and we said this yesterday. It's your sound, and therefore it was awesome. It doesn't matter. Like, I think when we're making sounds, and this is really important for your kids as well. They're going to make awful, horrendous sounds, right? You will not like them, but it's their sound, and you have to. That's really, really important. The fact that you made that sound makes it a beautiful sound, right? So you don't have to worry about the musicality and the performance piece that you think you haven't generated. I think anything you created is great. So well done, guys. Super. Thank you.
I can kind of intro things while they're setting up if you want. So I'm Carrie Gallagher. I'm a digital learning specialist from St. John's Prep in Danvers, Massachusetts, and director of education for a nonprofit called Connect Safely.
And I'm Sarah Gorman from Little Rock, Arkansas, and I teach 7th and 8th grade technology.
You want to go ahead? You want to set
It
up?
would require me to do two things.
Okay,
at
you
once.
can intro when we
I'm
need
Sean
to.
Gallup. I'm a English and economics teacher in Boulder, Colorado. And I'm Evan Worth. I'm an instructional technology instructor in Pepperell, Massachusetts.
I'm going to have Dan intro himself when we get to his part because he's deep right now. So Sarah wanted to create a voting booth for the upcoming election day for her students so that they could go into a voting booth and vote instead of having like the paper passed out here, vote at homeroom kind of thing. So it was like a real experience. And I wanted to do like a selfie booth in the classroom so that they could, go in, take a picture of themselves doing something that made them happy in their class, and those pictures could be broadcast all over the school to build excitement about what's going on in classrooms because I think teachers don't communicate enough. So we combined our ideas so that they could take a selfie in the voting booth after they voted, and that could be broadcasted because they were excited that they voted. And then Sarah also wanted it to play Hail to the Chief.
I couldn't get it out of my mind. Every time we talk about plans, I'd say, and then we use Sonic Pi to put in Hail to the Chief.
So
I got my wish.
What's cool about this project is that all of us have extremely different skill sets, and we were able to put them all to work. And this is a project that you could do not just across curricula, but across grade levels, starting with very basic writing Hail to the Chief in Sonic Pi. Sarah and I did it, and it
was amazing.
It was so fun. So, and you'll hear that in a moment. That was downloaded, recorded, and that is built into what Dan built.
Yes. So we wanted to. We were really impressed with the presentations that were kind of a model like the classroom, something that we could. So we wanted to do something that everybody could take with them. So to show that you don't need to do text-based stuff, we decided to do the most basic approach using our favorite Scratch cat here. So, so without further ado, the student comes in. So this could be the first assignment of the year. Requiring that they do, requiring the students to come up and ask the question, how do we wire something up, which leads you into 2 weeks of lessons of physical computing. It could be the first thing you do at the beginning of the year. So luckily they come in, they vote, it's recorded.
So what's cool about it is you can see it tracks the votes, it congratulates the student for voting, it says, hey, thanks for voting. But it's not over, because obviously our voting booth also has to be a selfie booth. So one thing that I want to note about the selfie booth is before we even started with the programming, Evan, you want to talk about that?
Yeah.
Right.
Well, being at the, and just fell over. Being at the Digital Harbor Foundation the last day, I've been staring at this awesome wall of 3D printers, and I was like, we got to 3D print something. And we wanted to make our selfie booth, so I found a really cool file online, and it's hard to see, but we 3D printed this file, and it's basically a little holder for the Raspberry Pi camera, and it just sticks in between the GPIO pins. You can just kind of wedge it in there. I had to cut it a little bit because it was a little long. We already have some stuff stuck in there, but it's a really nice way to keep it up, and it was a quick print. So thanks for letting me print that, guys.
Wait, and it stands up in the.
Yeah, it just stands up by the pins. Let me try to.
So all the resources that we used, all the articles and all the code and everything is stored in a Google Drive folder, and we're going to show you the bit.ly to that at the end of the presentation. So everything is there already.
I'm just going to hold it up because.
Including a ready-to-use rubric for those of you starting school next week.
Yeah, the rubric to grade
Print
this.
out,
Yeah. Good job, your screen.
Can you just
Move
grab
that.
that? I'm just holding this up.
So the cool thing is how much you can build on this. There's, even when we were watching these presentations, we thought, oh, we could take that bit of it and expand our project. So this is something you could start 1 year and then embellish it years after.
Great. Ready?
Yeah.
Great, and the idea is when people come in and vote, well, we sort of used everything we possibly could come up with except for the bear, so we figured this would actually be a really good spot for the bear to come in. But if you could just imagine that the bear had come in and voted, if you press the button, you can see the traffic light sort of counts down.
See the traffic light?
And then the selfie's created.
The selfie's created, and
Where did I put that cord?
we're moving over here.
That one.
We've got to untie your cables, let us rock, so
Yeah.
don't make it too messy.
All right, so it takes your selfie and it immediately uploads it to Dropbox. So for some of those districts that don't allow Twitter, you can have it go to Dropbox, and you'll have a nice Dropbox folder full of selfies.
So the idea is that you could take those selfies later to create promos for what you did on election day and just show the kids
Yeah.
pictures of themselves being really excited that they just
Oh, yeah.
voted.
So our newest selfie is right here. There's everybody. So on top of that, also, we were kind of coding against time, and right at the end, Sean was able to pull off our Pi the Vote account. So it also tweets our information, and it says, well, hopefully it updates. Let me refresh.
There we go.
Look at that. Every time you vote, it says, I just used @Pi the Vote, #Picademy, #election 2016.
And as a bonus, if you follow the Pi the Vote account, you can see all of our iterations of selfies.
Yeah. And you can see where we failed. We failed a lot early on.
We got better.
Okay, that was one fail.
I deleted some.
And the bit.ly link to the documents is on the Pi the Vote profile, so that gives you a reason to follow @Pi the Vote there. So.
Yeah, we have a nice Google Doc.
So there's the code for Hail to the Chief, there's the recording of Hail to the Chief, there's like if you want to take, we thought of like 17 other things we wish we had time to do with this project. So there's a bunch of those ideas there. Notes on how to do the scratch, and the steps with the links to all the articles that we actually found and used to make this happen because we didn't know how to do it. And then what else? Oh, the rubric with interdisciplinary connections to like business and social studies and stuff. And yeah.
And we have the link to the Pi camera thing that you could download too if you have a 3D printer.
You guys start last night.
Yeah. We did.
I
don't know where you guys went.
So thanks.
Thank you so much, everyone. That's been absolutely fantastic to hear from all of you. I'm right in the way here, so sorry. We're gonna end our hangout now. So thank you to anyone that's been watching. We're gonna say goodbye now from the Digital Harbour Foundation. So guys, can we give our audience a lovely wave from Digital Harbour? This is our latest cohort of our Raspberry Pi certified educators. Thank you very much.